Okay, good afternoon, everyone. How did your homework go? Any questions before we start? Yes, go on, Matt. Put your questions on chat. Matt, are you with me? Okay, anybody else? Any questions from the homework? Okay, okay, 1.9, number 14. And 6, number 1.7. So 1.9, number 14, 1.7, number 6. Okay, very well. We will do that, but before I do that, let me share with you Moodle. I know some of you are already checked it and some didn't, so please, all of you, make sure you enroll in it. So I'm going to share the screen a little bit and just view a little bit what you guys see in Moodle. Okay, so when you open Moodle, that's what I think you see because that's my side. I imagine you guys see the same. Basically, that's the course. You go in it. And you guys will see your assignment, like this assignment 1, chapter 9 and 10. That's the assignment that I will, actually, you guys will see something different than that. Dashboard, okay. You guys will go down here and you will see the assignment. Okay, so you click on the assignment and go to activity. And this is your assignment, will be right there. You click on preview quiz now, and then you start your assignment. Okay, that's really how it works. Now, I'm not going to do this assignment because this is up to you to do. So what I'm going to do is I'm going to show you how the questions are and what you guys can do. So I'm going to take something different. So another problem, something else. Okay. And I picked a problem, which I think it's easy, that we can discuss it together. So that's how your problems will be. And consider the following expression. So this is the expression they give us. And the question is expand it. So it means multiply out, distribute. So that's really what this problem is about. So you take this expression and you distribute. All right, so they tell you in the first text box, completely expand, but do not simplify your result by combining like term that appear. So they just want you to do the distribute only. And in the second part, they want you to combine like term. So that's a simple problem, but let us see what happened in here. So I'm going to do it and I'm going to do mistakes. So you guys see what happened there. So let us, for example, multiply them. S times minus 4s. So I'm going to get minus 4s squared. All right. Okay, minus 4s squared. And then plus 2s. Plus 2s. All right. And then minus 20s. So I'm just distributing slowly. And then the last one should be plus 10. Okay, sorry, plus 10. All right, did you see what I did? I tried not to do mistake in the first one, so I'll double check myself. So it's minus 4s squared plus 2s minus 20s plus 10. Okay, now then they tell you they want you to combine. So this time I'm going to do a mistake in combining. So minus 4s squared plus 2s minus 20. Okay, that's minus 18. All right, I will put minus 18s, but instead of putting plus 10, I'm going to put plus 8, for example. All right, and then save answer. Now Moodle will tell you how they interpret your answer. So you know that that's what you want. So it interpreted this way. Minus 4s squared plus 2s minus 20s plus 10. And interpret the second one this way. So if this is what you want, you're fine. If not, you go back and you fix it. Okay, now once you do that, save answer. Okay, now look what Moodle told me. Your answer is partially correct. All right, so it gave me a hint that my answer is not all correct. We first comment on your simplified answer. So your answer is correct. It means this one, I didn't do any mistake. All right, so it gives you really headline, what are you doing? We now comment on your simplified answer. And I tell you your answer is not correct because it's not equal to the original expression. Okay, so Moodle already told you that something is wrong. So I told you the first part is correct, the second one is. So now you have 4 attempts to a questions. After that, that's it, you have to submit it. So now you can have another attempt. So you can go ahead and fix your mistake. Okay, so let us say I fix it. So by fixing it, I goofed again and I put +1 here. All right, I did another mistake. Okay, save answer. Okay, it tells you how interpret it. Save answer again. Now it tells you your first comment on the simplified one, your answer is not correct. Again, on the second one, it tells me it's not correct. So again, I go back and I can fix the problem. So let me fix it. So finally, that's how it works. So it's really giving you hint. It doesn't solve it, but it gives you a hint. Now, finally, I'm going to put the correct answer that we think it's correct and save answer. Okay, that's how it interpret. I hit save answer again, and let's see what it's going to give me. Your answers are correct. Is that clear? And you have 4 attempts. After 4 attempts, it won't take anything anymore. All right, so that's how Moodle works, and that's how you have to do the problem. Now, once you're done with a problem, basically, you can go next page and do the other problem. And if you didn't finish a problem, you have what's called quiz navigation. You can go back to a problem and finish it. All right, so please get going, enroll in it, and your homework will be due next Wednesday, so you know what to do, okay? So now we stop sharing and I go back to your questions. All right, so I will do some of the problems you guys asked. So it's 1.9, number 14, and 1.7, number 6. So let's see what those are about. Okay. So 1.7, number 6. Okay, let me pull out the book. 1.7, number 6. Now 6 have A, B, C, D, and E. I will not do all of them, that's for sure. All right, I will pick 2 and do them, okay? So yes, you can if you exit Moodle, you can resume the assignment as long as you haven't finished your 4 attempts. Yes, of course. All right, so in problem number 7, I will actually pick 2 of them and then I will do them. So I will not do the whole thing because it's like repetition. So let us see, I pick C and I will pick E. Okay, so and let's do that. So C is the following. So have the function f of x equal, and I've done something like that. That's why I assigned them 5x plus 1. So you have this function. And the question is find all the values, for some reason I call them y, such that f of y is equal to 25. So basically here they are giving you the output and they are asking you for the input that gives an output of 25. Okay, so basically if you graph the function, I mean, you don't have to, but if you graph the function, so the function is going to be something like that. That's a typical parabola. And the question is, if the output is 25, they want us to find the input that gives an output of 25. So we do the following. Then we set y squared plus 5y plus 1 equal to 25 and solve for y. Okay, now as we said last time, since we have a y in here, the best way to solve is to make the whole thing equal to 0 because we can factor. So I take away minus 25 both sides. I take away minus 25. This would give me minus 24 here equal to 0. So I subtract minus 25. Now at this stage, I factor. That's why having it equal to 0 will allow me to factor. Now to factor, I have 24. Then I ask myself, okay, which numbers, when I multiply them, I will get 24, and when I add them, I get 5. So, anybody? Which numbers will do? Anyone find any numbers? 8 minus 3. I mean, there are a lot, but you have to go through them. I mean, no, there are 12 times 2, but they will not do the job. 8 and 3 will do the job. So I will have 3 here, 8, y and y, and then we have to make sure we get this. Since I have a plus, it means this has to go plus, minus. So you do it by trial and error, and then you check back. I mean, you don't stop here. I usually go back and check, am I doing it correctly? So y times y, it's y squared, correct. Plus 8y minus 3y, so plus 8 minus 3 plus 5 minus 24. So now we have two numbers. When you multiply them, is 0. So the only way when you multiply two numbers, you get 0 if one of them is 0. So if this is 0, it means one of them is 0, either this or that. Okay. The first one tells you that y should be equal to 3. The second one tells you that y is minus 8. Okay, and that's how we solve this problem. So if I go back to my picture, it means that the output is 25. It means this is supposed to be the minus 8. And this interrogation mark, this is the 3. Means the output is 25 for two values. Okay, so that's the graph and that's the math. Right, I do another one along those lines. No, actually, I'm going to do E, because I've never done E before, but I gave you a hint how you do that. So E is the following. Again, solving. So it's all about solving. This is x plus 3 over x minus 7. And the question is find all values of t such that f of t is negative 4. Okay, again, they are giving us the output. They want us which value of t I should plug in here so it spits out minus 4 for us. Okay, so again, we set f of t equal minus 4 and we solve. It means t plus 3, that's what we have, equal minus 4, and we solve for t. Okay, all right, so how do we solve for t in this case? Which hint I gave you on my note? I have a denominator which is problematic. How can I basically simplify this expression? Ideas? Multiply both sides by the denominator. So we multiply both sides by the denominator. So the math will be easy. Okay, so it means that I'll take this expression and equal minus 4. And I'm going to multiply both sides by t minus 7. So I multiply this by t minus 7 and this by t minus 7. Now the benefit of that is that those will simplify and this would leave me with t plus 3. And this is equal to, now I can distribute minus 4t plus 28. Okay, and now the rest is simple equation in t. We have to put the t together, constant term together, because this is of degree 1, is we don't have t squared to worry, and we finalize. So I'm going to add 4t to both sides first. We're going to add 4t. I will have t plus 4t plus 3 equal to 28. Then I take away the minus 3 from both sides, giving me, actually those immediately will give me 5t. This is 28 minus 3, 5t equal to 25, t equal to 5. Okay, so whenever we have an expression of this form, we have to multiply by t minus 7 both sides, so we will have a simpler equation to deal with. And now I can check. If I plug in 5 for t, I will have 5 plus 3, that's 8. I'm just checking my work. 5 minus 7, it's minus 2, that's minus 4. And we are doing the math correctly, okay? All right, so this will take care of 1.7, and you guys have one more question, and then we proceed. So your other question is 1.9, number 19 and 14. I will look at both of them and see which one. If they are similar, I will not do both. So 1.9. Okay. 1.9, number 14 and 9. Sorry, number 14 and which one? And 19. I didn't assign 19. I couldn't have. So if I did, it's by mistake, but I will definitely do number 14. So let's see what number 14 is about. Okay, the question is, so number 19, if I did, it was by mistake. I did not assign number 19. So suppose you have a function f that to each positive number assigns the perimeter of a square, each of whose side has length s. Is the function increasing or decreasing? So let us a little bit understand what this function does. What does this function do? So, you know, you have a square, that's a square, okay? And it's square. If the side of the square is s, what's the perimeter of the square? What's the perimeter? It's s plus s plus s plus s. The perimeter is nothing more than 4s. So the question is basically what my function does. Basically, it takes to s, to the side, it assigns the perimeter, which is 4s. Okay, and that's really the question. And now, is this function increasing? It means intuitively, as the side of the square gets larger, because here the input is the side of the square, the length, sorry, the length of the side, length of the side. And the output is the perimeter. So is this an increasing function? It means as the length increases, does the perimeter increases? Yes or not? Just intuitively without anything else. Ideas? What do you think?
It increases.
I can't hear you. Either speak up or write on chat. So what do you think? Is it an increasing function? Means as the length. So if you increase the length here, if you increase the length, will the perimeter increases? That's really the idea. Absolutely, it's an increasing function. And if you graph this, you know, just make sure. If you sit down and start graphing, so what does it mean graphing? It means I take this line and I put s and f of s, and I start plotting points. So for example, 0 is 0, because if the length is 0, of course, the perimeter is 0. 1, it's 4. 2, if the side is 2, the perimeter is 8. So if we start graphing, so 1, you get 4. 2, you get 8. So we can see that definitely this is going to be actually a straight line, and the graph is increasing. Okay? So this is S, and this is for S or the perimeter, right? Okay, so today we are going to move to section 1.10, and we will be talking about the average rate of change. So section 1.10. All right. So first, let's see what the idea behind it. I mean, and then we will work with it. So I'm going to ask you all a question, a simple question. So section 1.10, average rate of change. So let me ask you the following question. Suppose I give you a table that represents the population in a certain town. So it's a made up place, a made up numbers and everything. So this is time and this is the population. So let me call it P of T because P will stand for population. And I tell you in the year 2000, there were 10,000 people. Okay, and in 2005, we had 10,400. So the population increased a little bit. And in 2008, so we counted the population in 2008, the population was 10,670, let us say. Okay, and I ask you the following question. When the population was changing faster? So when is the population? When the population is changing faster. And I'm going to give you when. Was it changing faster between the time between the year 2000 and 2005 or between 2005 and 2008? Okay, when was it changing faster? Here or here? What would you say? So I'm having answers. Somebody's telling me it was changing faster between 2000 and 2005. And I had somebody telling me between 2005 and 2008. So we have to make up our mind. When was it changing faster? First, let us see how much is changing. Between 2000 and 2005, it's changed by how much? 10,000 all the way to 10,400. So it changed by 400% over a 5 years period. Make sense? By how much is changed between 2005 to 2008? And then by how much is changed from here to here? By how much is changed? By how much it increased? It was 10,400, 10,670. So by how much it's changed, let's take the difference between them. So if I take the difference between them, I should get 2070. Okay, so here it's changed by 2070. And the change, as you guys probably know, we usually denote it by delta P. Delta means the change in population. Okay, so anybody now have anything to say? Over 5 years period, it changed by 400. And here over 3 years period, it changed by 270. So how can we tell when it changed faster? Here or here? All right, a good way to say it, let's see which make the increase. Okay, let's make it very precise. Between here and here, it changed by 400 over a 5 years period. Correct? So it means how much per year? Over 5 years, it changed by 400. It means it changed 400 over 8 over this. It means it changed by 80 people per year. That's how much it averaged. So between 2000 and 2005, it was averaging 80 people per year. Between 2005 and 2008, how much was it averaging? So it changed. There were 270, but those 270 were spread over a period of 3 years. So it means, if you divide this, it means 90 people per year. So what's really happening here? Between 2000 and 2005, it's changed, but it averaged 80 per year. That's how fast it was changing. But between 2005 and 2008, okay, it was averaging 90 per year. So basically, where was it the population changing faster? It was definitely changing faster between 2005 and 2008. So what helped me to decide when it was changing faster is how much was it doing this per year? So per year, this is going much faster than before. This number we computed here, we're going to give it a name and we'll call it the average rate of change. So it's a number that tells us on average, by how much was the population changing per year. Now by not exactly how much, because between here and here it changed by 400, it's telling us how much per year. So to compute this, I say, okay, how much is changed over how long it took. 400 for 5 years, it means 80 per year. Okay. However, here is 270 over 3 years, it means averaging 90 per year. So the change was faster right there. All right. So that's the idea behind average rate of change, is to compare how fast actually is the output changing with the input. It's the speed at which things are changing. So now let me give you the formal definition of the average rate. So that's the intuition where it's going to come from. And now let us define it in a very formal way. So what's the average rate? Okay. All right, I'll read it slowly with you. So average rate of change. So suppose f is a function of x. F is a function of x. It means you have a rule that to every input x, it assigns a output f of x. Now, when we say the change in x, for x between a and b, so this is my function here. I'll draw it for you. So that's my function. And let us assume my function is like that, it's increasing. And this is a, that's a point A. And right here, that's a point B. Okay. Now, when we say about the change in x, for x from A to B, it means when x go from here to here, as the input increase from here to here, by how much it changes? Okay, it changes by B minus A. That's called the change in x. So the change in x is right there on the picture, is by how much the input change. Now, the change in f, or sometimes it's called a change in y, is by how much the output change. So the change in y is f of b minus f of a. Let us see it on the picture. Where is f of b minus f of a? So when x is a, f of a, we know that since this is the graph, it means f of a is right here. F of a is the vertical distance. So this is f of a. What is f of b? If this is b, f of b is this vertical distance. That's f of b. When I am taking f of b minus f of a, so it means when I'm thinking when the input goes from here to here, the output was here. And now the output is here. So f of b minus f of a on the graph is actually from here to here. That's f of b minus f of a. That's one way to see it. Okay, it's crucial to understand this picture. Now I'm going to show you f of b minus f of a in a different place because it's also important. So if I'm going to take this line here from here to here, this is also delta x because that's the same as that. And f of b minus f of a better way to see it, it's from here to here. That's f of b minus f of a. This is the output at b, this is the output at a. And this from here to here is what we call the delta y, or which is by how much the output changes. That's f of b minus f of a. All right, so that's how much the output changed, like how much the population changed, and this is how long it took. So that's only the change. Now, what's the average average rate of change? The average rate of change of a function for x between a and b is f of b minus f of a, which is we call the change in y, how much the output changed, over b minus a. It means how much the input changes. So the average rate of change is f of b minus f of a, that's how much the output changed, so that's the delta y, over b minus a, that's the delta x, which is by how much the input changes. So that's the average rate of change. Okay. All right, so let's take two examples. to apply that. The first example is just a table, and the second example is actually how to deal with it symbolically, as usual. So let us take this. Can I move the paper? All right. So first example, as I said, is just numbers, data. Let's do that. So I give you the table below, represent the temperature in degree Fahrenheit in Chicago on September 8, 2020. So you have a table. The input is time. The output is the temperature at this time. And I made up some numbers right there. Okay. So my first question is fairly simple. Find the average rate of change, of the function, which that I called it T, big T, because it stands for temperature, for the function for T between 0 and 6. So the question is, find the average rate for T between 0 and 6. And we're gonna use the formula verbatim, okay, and then interpret it. It means between, let us assume 0 is 12 midnight and 6 o'clock in the morning. So the question is, what's the average rate of change of the temperature between 0 and 6? All right, so what's the average rate? Average rate. We apply first the formula verbatim and then we'll give meaning to it. It's equal to, I want it between 0 and 6. It means it's the temperature at 6, so it's the change, minus the temperature at 0. It's basically the change in temperature. That's the change in temperature. Divided by 6 minus 0, which is the change in time. All right. Now let us compute the numbers. At 6 o'clock in the morning, it was 65. 12 midnight, it was 60 divided by 6, which gives me 5 over 6. Okay, so 5 over 6, which is, let's keep it 5 over 6, which is how much almost in decimal. So this would give me a better feeling. So 5 over 6 is how much a little bit in decimal. Okay, it's almost, usually I keep 0.83 in decimal. But now the question is, what does this number represent? Big deal, I found it. I applied the formula of the verbatim. What does it represent? Can anybody explain to me? What's the unit we can assign to this number? What's the unit we can assign to this number? Okay, degree, because this tells me that by how much the temperature changed per hour. So when I assign the unit, degree Fahrenheit per hour, I'm really giving you meaning to this expression. It means on average, the temperature was rising by 0.83 degree per hour. That's really what it's really telling us. But degree is important. It's not 0.83 degree, it's 0.83 degree per hour. That's how, because I have to tell you what the average rate tells you is the change per unit. So it changed 5 degrees during 6 hours. It means on average 0.83 per hour. And that's really what the average rate, it tells you, it's like your speed. You know, when you talk about speed, you always say, okay, I'm driving 60 miles per hour. Average rate is a speed. It's how fast the temperature is changing between 0 and 6. It's changing on an average of 0.3 degrees per hour. That's really the meaning of average, is how fast things are changing. How fast are changing. All right. Now let's take another one. The average rate between 12 and 18. Okay, so again, we're gonna do it verbatim. We're following the formula and then understand it. So now between 12 noon and 18, 6 o'clock in the afternoon, of course, all of us realize that the temperature is actually decreasing. Makes sense. So what's the average rate? It's always the value at the higher input minus the lower input. So it means the temperature at 18 minus the temperature at 12 over 18 minus 12, verbatim. It means the change in temperature over the change in time. All right, let's compute that. At 18, the temperature was 70. Minus. At 12, the temperature was 75. 18 minus 12, it's 6. Okay, so this is gonna give me minus 5 over 6. All right, so this time we have a minus sign. What do you think the minus sign reflect in this problem? So the average rate could be minus, of negative, sorry. What does the negative sign reflect what in the problem? What the negative sign reflect is that the function decreasing. Exactly, the temperature is going down. Okay, and that's important because if we always have positive number, this is if I tell you temperature is changing by 83 degrees, you have the right per hour, you have the right telling me, is it increasing by 83 or decreasing by 83? So the sign is important because it actually tells me what's happening in here. So the reason it's negative because it went down. The temperature here is larger than the temperature at 18. So we have negative sign. And the unit is the same. So, or this problem, I'm putting it in decimal because so I'll give you an idea what it is. So it means it's going down by minus 83 degrees per hour. So that's really what the importance of the average rate. It actually talks about how fast things are changing, how fast things are changing, okay? Okay, now we're gonna take one last problem, and this is purely symbolic. It doesn't have any meaning attached to it. In other words, the problem doesn't have, the input and output don't have physical meaning. If they have physical meaning, the average rates tell us usually how fast is the output changing per unit of input. Actually, let me write it down. So usually the average rate tell us how fast is the output changing or output changing. So how fast the output changing per unit change in input, per unit change in input. Means if the input changed by 1 unit, the average rate tells us by how much the output changed. And this is important, per unit. So this tells me per unit is going down by 0.83 degrees. This tells me per hour is going down by 0.83. So the average rate tells us how fast is the output changing per unit change in input. That's what the average rate represents for us. That's the importance of it. It's about speed. All right. Let me take now, we're gonna take another problem, which is purely, as I said, purely mechanical. So we know how to compute those average in a pure mechanical way. So suppose I take the following function, f of x equal. So this problem does not have any meaning or whatsoever. So f of x equal, let us say, x squared plus 4. Very simple function, okay? And my first question is find the average rate of change. Average rate of change. And I have to tell you on which interval. So let us say for x between 1 and 5. X between 1 and 5. Okay, so what's the average rate? I will find it and then I will show you again a little bit on a picture, those quantities we are computing. So the average rate is, so since I want on this interval, so it's the change in f, how much f changes between those, divided by how much x changes. So that's really what it is in a simple format. So this is going to be equal to Now f of 5, you can compute it on the side if you want, or you can plug it in. So what is f of 5? It's 5 squared plus 4, which is 29. So this is going to give me, actually, I'm going to put it here again. So that's the 5 squared plus 4 minus 1 squared plus 4 divided by 4. Okay, so this will be equal. So the rest is simple. That's going to give me 29. That's going to give me a 5 over 4. So that will give me 24 over 4, which is equal to 12. So this time, because I don't have physical meaning to the function, I just get a number. Now on the graph, let us see what everything is. Okay. Somebody is correcting me. Oh, thank you very much. Thanks. Sorry, that's equal to 6. Thank you, Cooper. All right. So now let us see this a little bit graphically. What do I mean by graphically? My function is x squared plus 4. So it's like a parabola pushed up by 4 units. So that's my function. And I need to compute the average rate for x between 1 and 5. So let's see what it is. This is 1. And this is 5. Okay, those are, and this is the change in x. So x is changing from here to here. When x changes, my output, f of 1 was here. And when x hit 5, my f5 is right here. So on my picture here, this is f of 1. This is f of 5. Do you guys see it? So what is the change in f? What is f of 5 minus f of 1 on the picture? F of 5 minus f of 1 is from here to here. This is the f of 5 minus f of 1. If you remember, it's like the rise on a line. So these are your points, those 2 points, and it's how much the output changed by going from 1 to 5. So this is the f of 5 minus the f of 1. Now, here, this from here to here, it's the 5 minus 1, because that's a 5. You're taking away 1. This is the 5 minus 1 that we call the change in x, and this is what we call the change in y. So that's how much the output changed over the input. So that's really the average rate. Now, for those who remember slope of a line, we can this really actually is a slope. This is the average rate is a slope, and it's actually the slope of this line right there. So for those who remember the slope, if you take this line, this dashed line here, the slope of this line is the rise over the run, which is basically f of 5 minus f of 1 divided by that. So one way to interpret the average rate graphically is actually the slope of the line which join those 2 points. It's joined the point 1 f of 1 and 5 f of 5. Okay, because it's just rise over run. That's what it is graphically. All right, so let's do one more. And again, the one I'm going to do is symbolic. I mean, I'm going to take the same function, and the reason is because if you guys move on, eventually in math, you will need this kind of symbolism. So my last problem before we go to the quiz is the following. I'm going to take the same function, f of x equal x squared plus 4. And as I said, I will do it a little bit symbolically. And the question is, find the average rate for x between, okay, you're not going to like it, 2 and a certain thing called 2 plus h. Okay, so this problem is purely symbolic, but we should be able to learn how to do it. All right, so let's compute the average rate in this situation. All right, the formula is the same, so there is nothing in. So what's the average rate? Okay, it's f output at 2 plus h minus the output at 2 divided by, oh, I'll get back to you, Zach. Divided by 2 plus h minus 2. Okay, follow with me now, Zach, and I will go back to this. Okay, so finding this average rate, it's just computing this ratio. All right, let us compute this ratio easily. What's f of 2 plus h? I'm going to put a big, sorry, there's nothing here, minus. So I'm going to first put f of 2 plus h, and we practice this. What is f of 2 plus h? What does f do? It takes your input, square it, and it adds 4 to it. Okay, and here, what does f do to 2? It takes your input, square it, and add 4 to it. And those just simplify, and we get h. So that's the symbolic part. The rest is just algebra, and we will do it slowly. Okay, that's 4 plus 4, that's 8. And let's see what here we get. 2 plus h squared is 2 plus h, quantity 2 plus h, plus 4. So that's why I remind us what, stuff we've done before. So now this will give me 4, I distribute, plus 2h, plus 2h, I'm distributing. Okay, plus h squared, plus 4, minus 8. Okay, and the rest is simple. Please, if I'm going fast, let me know. So what we have here, let's see, combine like term. 4 plus 4, it's 8, minus 8. That's simple. And then can combine those two. 4h plus h squared, the whole thing divided by h. So as I said, this is a symbolic problem that we should know how to handle. Okay, now we're done, but we can do a little bit better. Do you think we can do anything better at this stage? Look at the algebra, take out NH, I think, because we can. We can factor out NH, will give me that. I'm just factoring it out. I factored the H out, I will be left with 4 plus H. And the benefit is that we can simplify that and will give me 4 plus H, okay? So this problem is, as I said, purely symbolic, but we have to learn how to do both of them. Okay, any questions about this one? Okay, so I will go back to this problem, which one of your classmates is asking me. The answer here is 6. Forget about this picture for a split of a second, and then I will go back to it. So it's f of 5 minus f of 1 over 5 minus 1. F of 5 is the 29. F of 1 is the 5 over 4, which is 5 minus 1. 29 minus 5 give me 24 over 4, which is equal to 6. So the answer is actually 6. That's the answer to the problem. All right? Got it, Zach? Now the rest is a graphical interpretation of what we are doing, which is, I think, is important. So the graphical interpretation is the following. This is the function x squared plus 4. It means if you take the f of x equal x squared plus 4, and so if you take f of x equal x squared plus 4, which most of you, I think, know that's a parabola, and you start plotting point x squared plus 4, you plot point, you get this kind of graph. So that's really what the graph is. So what I'm trying to do here with 6, I'm trying basically to interpret those two pieces. So graphically, this is 1, this is 5. If x is 1, that's the output. At 5, that's the output. So the change it means f of 5 minus f of 1. I want you to be able to see it graphically. It means by how much we rise when x go from 1 to 5. So your output changed. If we were right there, your output is right there. So that's how much we changed. So that's the graphical interpretation. 6 is the answer. And delta x is by going from 1 to 5, how much we changed. So we were here, we are right here. So f of 5 minus f of 1 is this rise, and 5 minus 1 is this run. And the average rate is the ratio between this rise and the run. So it's the ratio between f of 5 minus f of 1 and 5 minus 1. And here I said, for those of us who remember the slope, this should remind us the slope, but the slope of which line? If I take this point and this point, it's the slope of the line connecting them. So this piece here is not the answer. The answer is 6. This piece here is the graphical interpretation of the average rate. So that's the graphical interpretation of the average rate. The average rate. Okay, so this is the answer, but that's the graphical interpretation. So graphically, that's what the average rate would represent. In terms of meaning, it tells me how fast the output changes per unit change in input. Okay. Any other questions, please? Okay, so I'll stop then at this stage. Your quiz is fairly simple. It shouldn't take long at all. I think I opened it at 1:20. So please, over the weekend, all of you have to go to Moodle. You should do your homework, and it's due Wednesday evening. But most of you should have done it before that. And this will give you, on Tuesday, if you have any questions, not about what I assign, not about the Moodle homework. I usually assign exercises from the book, which are fairly similar to the Moodle homework. And I expect you to ask me questions from the practice problem I assign, though that they are not for grade, okay? So you will have practice, and then you will have your Moodle homework. Any questions, anything? All right, so you guys can start taking your quiz, get going. You know what to do, I imagine by now. All right, anybody knows what to do? So you go to Brightspace, and actually I will share the screen just to make sure everybody is on. Yes. No. The quiz is on Brightspace. The quiz on Brightspace. Only homework will be on Moodle. Everything else remain the same. So as usual, you go to a Brightspace, you go to the content area, nothing have changed. And then you go to quiz, you open the quiz as usual, and you do exactly what we always do. You take the quiz, and then you upload it into Brightspace. Okay? Is that clear? Yes, you're doing the quiz right now. Yes, as usual, nothing have changed. Nothing have changed, except now that you use Moodle to do extra problems, and those will be graded. So get going.